In this example, we're going to solve an interesting problem involving quadratic equations. Let's find the values of the parameter k for which this expression x squared plus k plus 1x plus 2k is greater than 0. So let's find the values of the parameter k for which this inequality holds for all real x. So once again, here I'm having infinitely many quadratics. So for every value of the parameter k, I'm having one quadratic. And I'm trying to adjust the value of the parameter k so that for all values of x and that fixed value of k, I get something positive. So no matter how I choose, so I want to fix k so that no matter how nasty I choose x, I always get something positive. Okay. In order for this quadratic to be positive, what do we need to happen? Well, look, the quadratic opens upwards, right? So this quadratic opens up because the leading coefficient is greater than 0. So if a parabola opens downwards, it always gets to be negative, no matter how I choose its linear coefficient and its constant term, right? If a parabola opens downwards, it always attains negative height. But this is the leading coefficient here is positive, so we're guaranteed that it is. Well, let's not say we're guaranteed, but it is possible that we can choose the parameter k so as to make the graph of this function lie entirely above the x-axis. So can we choose k? Can we choose? So can I choose k so that the graph of my parabola lies entirely above the x-axis? So that's what the problem is about. So the leading coefficient is positive, as already discussed, so the graph opens up. So our picture is going to be something like this. So what you see here plotted by the computer is, of course, I have already solved this problem before I started doing the slide. So I know certain allowed values for k, which make this parabola sit above the x-axis, and I've selected one such value of k, and I've plotted for you one such parabola. Okay. So the graph of my function is going to open up. So it's going to look something like that. Now, for the graph of a function to be above the x-axis, it means that the graph does not intersect the x-axis, which means that the quadratic has no real solutions. What are the roots of this quadratic here? Just a reminder, the roots of the quadratic were the numbers that you get when you solve the quadratic equation. So what I'm really asking you is to set x squared plus k plus 1 times x plus 2k. I'm asking you to set it equal to 0 and to solve. So when I'm asking you for the roots of this equation, I'm asking you to solve that equation that you see here. And what are the roots? What are the roots of that equation? I'm sure you solved it correctly. The roots are, well, this is a quadratic equation. So the roots are minus b plus or minus a radical of b squared minus 4ac over 2a. Of course, I didn't expect you to already have everything simplified, but I expected you to acknowledge the fact that we have a ready-made formula for finding the roots of a quadratic, and I expected you to recite that formula. Minus b plus or minus a radical of b squared minus 4ac over 2a. Okay, so for this quadratic to have no real solutions, right, I need no real solutions for this quadratic, that means that this number here must be negative. So for me to not have real solutions, I need to have that b squared minus 4ac, the discriminant, that's d, the discriminant. So I need that the discriminant be negative. I need to have that this discriminant here is negative, right, because if the discriminant is positive or equal to 0, I do have real roots. So I do have that the graph of my function intersects the x-axis, and that's not what I want. Okay, so I need to have that b squared minus 4ac is less than 0. Now b is equal to k plus 1, a is equal to 1, because I'm having 1 times x squared, so a really is equal to 1, and c is equal to 2k, so my c is equal to 2k. So, so now I have eliminated a, b, and c, and I'm left with an inequality with respect to k. So let me solve that inequality. And now k plus 1 squared, that's the formula for squaring things, so I'm getting k squared plus 2 times k plus 1. Once again, what am I using? I'm using the fact that a plus b squared equals a squared plus 2ab plus b squared, which means that if I take a plus 1 squared, I'm getting a squared plus 2 times a times 1 plus 1 squared, which happens to be a squared plus 2a plus 1. Exactly what I have here. Whoops! I should have used k rather than a, right? If I were to use k here, I would have gotten what's written over here. Okay. Now 4 times 2, that is 8. So 4 times 2, that is 8. So I'm almost done simplifying. 2k minus 8k, that is negative 6k. Okay. So that expression now, I can factor it. That's k minus k1 times k minus k2, where k1 and k2 are the roots of my quadratic. Okay. So what are the values of k1 and k2? Let's see. Can we guess these roots? Okay, let's not guess it. Let's use the formula minus b plus or minus radical of b squared minus 4ac over 2a. So b equals negative 6. A equals 1, because I'm having 1 times k squared here, and c is equal to 1. By the way, notice that I didn't write a, b, and c here because I've already used the letters a, b, and c for a different quadratic, so I shouldn't be using the letters a, b, and c here. Okay, so there we go. We have our two solutions, k1 and k2. Now minus 6 is plus 6, and let's check what this turns out to be. Negative 6 squared minus 4 times 1 times 1, that is 36, minus 4, which is 32. So that is 32 indeed. Okay. Now I run out of space. You can see this problem is relatively long, so I run out of space. So what I'm going to do is I'm going to hide. So I'm going to hide some of these formulas. So I'm going to hide this stuff. So all that I'll leave out is my work so far, and I'm going to let me move my work upstairs. Now, if you're following this solution on a pen and paper, simply use more paper. So there we go. Here's what happened so far. Here are my two solutions so far. Now let's continue. Now 6 is 2 times 3. And radical of 32, well, 32 is 8 times 4. So radical of 32 is radical of 4 times radical of 8. Why did I do that weird splitting? So why did I split radical of 32 into radical of 8 times radical of 4? Well, because radical of 4, that is equal to 2. Which means that this expression here is equal to 2, and I can factor out a 2 from here and from there. By the way, that's also why I split the 6 into 2 times 3. So I can factor out the 2 from here and from there. So I can factor out the 2, and finally I can cancel out the 2. as seen here, to get 3 plus or minus radical of 8. So these are my values for the parameters k1 and k2. Okay, so I found the numbers k1 and k2. Now I run again out of space, so if you don't mind, I'm going to erase part of what you see here. So I'm going to move my formulas upstairs. There we go. All right, we're almost done. So let's see what is going on. So I need to solve a quadratic. I need to solve a quadratic inequality. So here what I'm seeing is a function of k. So I'm having some function y equal to k plus 1 squared minus 8 times k, right? So that's this expression here. That's a quadratic function. We can also uncover here the parentheses and rewrite it as a proper quadratic function. If you remember, when we uncover the parentheses, that turns out to be k squared. What was it? Minus 6k plus 1, something of that sort, right? So so that function here is k squared minus 6k plus 1, and I can plot it. So I can plot that function, and here's the first solution k1, and here's the second solution k2. And I need to find where the graph of that function, is negative. So, but the graph of that function is negative when k is somewhere here, right? So when k is between k1 and k2, that's where the graph of that quadratic is below the x-axis, which means that this quantity here is negative. So so that means that well, you can see from the graph of the parabola, you can see that that parabola is positive over this interval. So over this interval, the graph of the parabola is positive, right? So the graph of the parabola sits above the x-axis. Over this interval, the graph of the parabola continues being positive over here, but between k1 and k2, it is negative. Oops. So between k1 and k2, I'm having a negative value of the quadratic function. So I get that my final answer is that the parameter k must be between 3 minus radical of 8 and 3 plus radical of 8. So finally, I get my answer. The parameter k must be chosen between 3 minus radical of 8 and 3 plus radical of 8. Now notice that when I write my final answer, I'm saying that the parameter k must sit in a certain interval, and I'm using open parentheses. So why open parentheses? Why open interval? Right, so just a reminder, this is an interval, so when I have the open parentheses, they stand for an open interval. But why is this interval open? Well, why is this interval open? Well, because this was non-strict inequality. So when this inequality here is non-strict, so that means greater than or less than, not greater than or equal to, or less than or equal to. So when the inequality is strict, no equality sign, strict inequality, then I have to use an open interval for my inequality solution. That solves my problem.